Good evening, everyone. Welcome to fourth day of the program, fourth edition of the online 5-day hands-on training program on mixed method data analysis with MAXQDA software. This particular program is jointly organized by Gujarat National University, Gandhinagar, law teachers in India. So we have completed successfully 3 days, and today we are going to start with the fourth day of the program, that is quantitative data analysis. So we are going to discuss about how one can manage the quantitative data, how we can analyze quantitative data with the help of MAXQDA software. So as a part of today's session, you can call it as a quantitative data or statistical data. As a part of the outline, as we already downloaded the MAXQDA software. In case those who missed the day 2 session, you can check the Google Drive link. You can check my YouTube channel, which I already shared with you all. As a part of day 2, we discussed about how to install it, what is the interface of MAXQDA, and how one can deal with the text files. Okay. Coming to the next part. Today, we are going to deal with the statistical analysis. So how to deal with the statistical data. Okay. How to import the files, how to enter the data manually. And if there are any data transformation techniques, how to handle it. And how one can prepare the frequencies, cross tabulations, charts. And you can also see certain inferential statistical techniques like chi-square test, independent sample test, ANOVA test, correlation, and reliability test. So these are some of the statistical tests we are going to conduct today. Let me start with session. Imagine that you have conducted some study. You already have some research tool in your mind. As a part of your data collection, we have prepared certain research tool. So if you look at your research tool, you can able to see that we'll have certain demographic profile like age, gender, like depends on the context. You might be having a lot of questions, like 20 questions, 30 questions, or you might be dealing with 2 different stakeholders, 2 different respondents. But when it comes to the quantitative data, whether you hang 20 questions or 50 questions, you can see 4 types of data, like nominal data, ordinal data, interval data, ratio data. Having knowledge about types of data is very helpful. It is very essential in terms of understanding what kind of statistical test one can conduct it. So I'll discuss in coming slides how having knowledge about levels of data, like nominal data. Whenever you're going to classify data in the form of specific labels, specific categories, we call it as a nominal data. If you're having any, like for example, current level of study, like UG, PG, doctorate. If you're putting data in the form of specific ranking, specific order, specific positioning, like senior employee, junior employee, middle level employee, like UG, PG, PhD, that is called as ordinal data. If you have data like, we also have interval data, ratio data. If you are measuring height, like 56.5 inches or 5.6 feet, right? It's a continuous we have it. For example, if you're asking how many children do you have, 2 children, we have discrete data. So having about types of data is very essential, very helpful to understand whether it is coming under categorical data or metric data. Categorical means nominal and ordinal comes under categorical data. Interval and ratio comes under metric data. Okay. Now, once we have clarity with the types of data, what kind of statistical tests that you want to conduct it? Whether you want to conduct descriptive statistics or inferential statistics. How descriptive statistics is different from inferential statistics. The main objective of descriptive statistics to describe what you observed, what study that you are conducting it. Like we have measures of central tendency, like mean, median, mode. We have measures of dispersion, like we have variance, standard deviation, range. If you want to describe as a part of your study, and if you are collecting small sample, if your purpose is to describe, then they go for descriptive statistics. If my purpose is come up with some kind of conclusion. I want to inform my findings with the rest of the society, or rest of the particular community, rest of the district, rest of the state. It may be anything. So I'm going to use some hypothesis. I'm going to test my hypothesis, and I'll go for large sample size. I'll collect the data. My main objective is to generalize my research findings with the rest of the population. So when it comes to the descriptive statistics, we'll go with mean, median, mode. With the help of the MAXQDA, we are going to conduct a mean, median, we'll also check it, frequency, cross tabulations. Similarly, when it comes to the inferential statistics, with the help of MAXQDA, we are going to conduct t-test, ANOVA, correlation, some of the statistical tests we are going to conduct it for both descriptive as well as inferential statistics. Further, within the inferential statistics, I'll come to the inferential statistics later on. Now, let me start with the descriptive statistics. Along with the descriptive statistics, I can also use certain charts, certain figures to present my data. Now, most of the time, your master degree students, PhD scholars, they might be preparing various charts. If you ask, what is the justification for it? What is the reason behind using pie chart? Your master degree student or MPhil student might be preparing around 20 variables they have. Out of 20 variables, 15 to 17 variables, they used to come up with pie chart or some particular bar chart. They don't know what is the reason, what is the justification, why they have prepared the pie chart, why they have prepared the bar chart. Still, I'm getting the message. My voice is not clear. Is it so? Professor Nisha Bharti is saying, am I audible to all of you? Somebody can check it out. Is there any issue with my? It's clear? It's clear? Okay, thank you. Now, the problem is that when it comes to selecting any particular chart, is there any scope? What is the reason for it? If you look at overall the chart, overall the figures that we have it, we have 4 reasons. Whether am I looking at a relationship, whether I'm looking at a relationship, whether I'm looking at distribution of the data, whether I'm looking at comparison. Like for example, when I say comparison, I just want to know when gender difference, performance of employees based on their gender. Like for example, if you have assistant professor, associate professor, and what is their APA score? The respondents or the employees belongs to assistant professor category. Are they having more performance? Are professors having more APA score? If you want to compare it, I can go with bar chart. I can go with the multiple bar chart. Right. Similarly, if I want to see that when Virendra Sehwag is coming to the batting, what is the current run score? If you want to compare with 2 batsmen, how they're able to perform it. I'm sure all of you might be watching cricket. If there is a cricket match going on between India and Pakistan, when India was in 10th over, what was the current run score? And when it reached the 45th over, what is the trend? Like 10th over to the 45th over, what are the fluctuations? In which over we got high score, which over we got less score. If I want to see that changing particular time period wise, so that way also I can use. If I want to see that, I can use line chart. If you want to see the composition, I can go with the pie chart. If you want to see the distribution, you can see that like histogram, like column histograms, we have it. If you want to see, for example, employee annual expenses, annual income. Imagine that there are so many faculty members here, professors here. Now, if you want to see that your annual income and annual expenses, there are 2 quantitative variables. If you want to look at the 2 quantitative variables, if one variable increases, other variable is increasing or decreasing. In that case, I used to go with scatter plot. Whenever I have 2 quantitative variables, annual income, like demand and supply, price and demand. Take it any example. IQ score of the students and their academic performance. If you have 2 quantitative variables, I'll go with the scatter plot. If I'm looking at the distribution of different religious community members like Hindu, Muslim, Christian, if there are total 100 respondents, I want to see how many people belongs to Hindu religion, how many people belongs to Muslim religion, how many people belongs to Jains. So in that case, I'll go with the composition wise pie chart. So within that composition, we have different kind of categories. So having knowledge about or having purpose in your mind is very essential, very important. When you're trying to look at the relationship, distribution, comparison, or composition. So based on that, we have good number of charts are available. One can able to decide what kind of chart is the right choice for you. Okay. Let me go to next. I think we'll start with the hands-on practice. I believe all of you must have downloaded the data sets. I have given today two new files, other than the interview transcripts. Like scale data is one, quantitative data, workload, and stress. These are the two files I have given. We are going to start with first one. Some of you are sending messages saying that you didn't find the day 3 session. Day 3 session I have just uploaded in the Google Drive link. I'll be working on your offline, some functionality maybe. I hope I'm audible to all of you, right? So day 3 will be uploaded as a part of the YouTube, maybe within a week. Okay. So you can see the Google Drive link. In this Google Drive link, we have quantitative data, workload, and stress. Please check it, the Google Drive link. There are 2 sample files. Please open your MAXQDA. Please open your MAXQDA. Please open your MAXQDA application. Now, whenever you open the MAXQDA application, it is asking whether you want to create new project or you want to open the existing project. So what I'll do, I'll just create new project. In order to create the new project, just click on new. And what is the project name that you're going to give? Where you want to save it? My project name today, Statistical Analysis using MAXQDA. My title of the project is Statistical Analysis using MAXQDA. Wherever you want to save this file, this particular project, you can save it. Today is day 4. From last 3 days, we are using MAXQDA. So I hope all of you knows how to create the project, right? So just give the name and select the location or destination where you want to save this project. Okay, just click on save. Now look at this on the top of the ribbon bar. Statistical Analysis using MAXQDA. That is the title of the project. Now we have to import the files. Now before importing the files like survey data, there are a number of options. Like I can go with directly importing file from here, like Excel file, SurveyMonkey, SPSS file. Apart from that, if you look at the ribbon bar on the top of the window, from last to second, if you count from home to here, 10th number, stats. There is a menu. Title of the menu is stat. Just click on this particular stat and you can able to see there are a couple of options. We got it. Please come to this particular ribbon bar, stats, statistics ribbon bar. And we have there is an option called start with external file. Start with external file. Just click on this particular file and go to the particular destination wherever you have saved your file. Wherever you have saved this particular file, go to the particular destination, select the particular file, click on open. As I mentioned on day 2, one can import SPSS file, Excel file as a part of the MAXQDA. The moment I selected the file and it's showing the preview of the file that we are trying to import it. Just click on import. The moment I click on the import, it just opened the entire data. Just to open the entire data that we got it. Let's try to understand, first of all, interface of the MAXQDA statistics ribbon bar. We have file. Generally, we use it for opening the file, saving the file. View. As a part of the MAXQDA statistics window, statistics ribbon bar, it's showing that we have three windows: data editor, variable list, output viewer. Look at the bottom of your screen, like data editor, like this is the data, like the number of respondents. We have 30 responses. We have collected data from 30 responses. Next one is variable list. Variable list is nothing but the list of the questions that you have designed, that you have prepared as a part of your research tool or survey. So we have respondent number, that is questioning number, stress level, coping strategies, workplace environment, like this is a Likert scale, coping strategies 1 to 5 Likert scale, stress level 1 to 10. So we collected data from the employees who are working as healthcare workers. They are the healthcare workers, but still we are trying to understand what kind of stress we have. Context is the same, just like in the previous class. We know what is the case study. Those who have missed yesterday, please watch the recording session, yesterday's recording session. Team support, again 1 to 5. So you're asking very poor to excellent support. Management support, very poor to excellent support. Burnout, you're asking rank 1 to 10 burnout, how much they are burning out. In the satisfaction, how much satisfied they are. So we have so many Likert scale statements. And we have data like gender, age group, department. Okay. Now, just come to the data, gender. Here we have to code the data. If you look at the data editor, it is showing male, female, male, female, male, female. It is your online data. We have used certain Google form. Let's take, for example, Dr. Kalpesh and myself have collected data from all of you about your participant details. Right? We have filled the online form. Now, while I'm filling this particular online form, I imported this particular data in my MAXQDA. I can't start my data analysis immediately. I need to go with the variables. I need to do certain data coding. I need to clean my data. I need to see the data that I have is it ready for the analysis part. Now, if you look at the gender, it is not having any values like 1 for male, 2 for female and all, right? So in that case, we need to complete the data cleaning procedure. Then only you can go for conducting statistical test. Let's take for example here, gender. What type of variable type it is? If I click on this variable here, like for example here, it is showing that in text, like male, female is a text. Job satisfaction 1 to 5. We got the number, like for example, look at that here. We got the responses from our respondents. They have given 1 to 5 rank, 1 to 10 rank they have given. They are in number. But we need to clean this particular data. We need to code this particular data. Now, let's take for example, let me go with 1 or 2. Gender, I want to code it. How to code it? Just click on values in the gender variable. Come to the value labels. You can see there are 3 dots. Just click on it. The moment I click on the 3 dots, I got value labels window. Now here I'm going to give 1 for male, 2 for female, 2 for females. Now it depends on the number of responses that you have it. For example, if you have one more category, 3 for transgender, I can able to give it. Or there's a possibility that some of them they do not disclose. So I can give 3 for any other category. Just click on OK. You can see that 1 for male, 2 for female. Next one, department. Just come to the data editor. We have ICU department, emergency department, outpatients department. Now, if you want to give the coding part, you should know how you have prepared your coding in your research tool. This is my research tool. My research tool will help me how I have done the coding before collecting data. Because we are going to prepare our structured survey or tool, and we'll be very careful while designing it. And we'll also go for pilot study. Depends on the type of tool that you collected, you use it. We'll also go for pilot study to understand whether the tool that you designed, is it really good enough to go ahead with that in terms of content, in terms of structure, in terms of the amount of knowledge that you want to test, the kind of concept that you want to test. Okay. Now, just let me show you this. When I talk about the department categories, we have ICU. Let's take for example here. ICU is the one, emergency is the one, outpatient is the one. So just come to the variable list. Again, click on value labels. There are 3 dots. Just click on it. First one is ICU. Just type it, please. I hope you are following with me. One label for ICU, 2 for emergency, 3 for outpatients. Please check the spelling mistakes if there are any mistakes. Outpatients. So we have 1 emergency, 1 for ICU, 2 for emergency, 3 for outpatients. Just click on OK. So we have certain variables. We have done the coding part, and rest, I believe you can able to see that. Next window, we have output viewer. Whenever we perform any kind of statistical test, we are going to see results in this particular window. So we'll come to this particular window after some period of time. Please come to the data editor now. Please come to the data editor now. Somebody asking whether it is required to change measurement. Having knowledge about types of data is very essential. Whether you change here or not, it is not going to affect it. But having knowledge about types of data like measurement, nominal data, ordinal data, interval data, it is going to help you. Okay. Missing values also, if you think there are more number of missing values, and if you want to represent them, you can give some identification like 9 or 999. Right now, I'm not going to have any missing values here. Okay. So once we complete your data, cleaning the data, and you look at the what kind of data that you have it, you'll start performing certain descriptive statistics. Now, I just want to prepare the frequency table. I want to prepare the frequency table. In order to prepare the frequency table, as you can see that there is an option called descriptive statistics. Just click on descriptives. There is an option called frequencies. I want to select gender. At a time, I want to select department. I want to prepare the frequency table, not cross tabulation, frequency table. Gender and department I have selected. I'm repeating again. Go to the descriptive statistics. Choose the type of the test that you want to conduct it. I want to conduct frequencies. So I have selected frequencies. And what are the variables I want to check it? I want to check with the gender. Second one, I want to check with the department. After selecting the variables that you want to conduct frequencies, just click on OK. From here to here, we brought it. Just click on OK. Now here you can see that I got the frequencies window. And here, out of 50 respondents, we have 15 male, 15 female responses we have it. Means 50% responses we have it. Okay. Now, what is showing here? We don't have any missing values. Why I'm presenting this particular data in my output, like in paper, my research report. I don't want to show this particular missing values because we don't have any missing values here, right? So what I'll do, I'll select the particular entire row. Right click. There is an option called delete. I can delete it. Okay. And even I don't need this particular percentage valid and the percentage cumulative, but let it have it. So I need to present these two data only, frequency, percentages, as a part of my output. In addition to the frequency table, or maybe I also want to use certain charts. Instead of using continuously tables, one-time table, one-time chart, I want to prepare it. Okay. So if you look at the top of this ribbon window, we have a couple of options. I can able to prepare the chart. Here. Female, male, we have it. Now, if you look at the right side of this particular window, I have also option called pie chart. I also have option horizontal, vertical. So I can choose. Apart from that, here right now it's presenting in the form of percentages. I can also put it in the form of legends, with legends, without legends. Legends means the categories. See here right now we have right side female, male. If I click on it, it will go. But I want to display so that it should be self-explanatory. People should be able to understand. Okay. I can prepare grid lines. Right now we have grid lines. I don't want it. I can remove it. But if you want it, I can keep it. I want to keep the title for the chart. If I want to keep it on bottom, on top of it, where you want to keep it. It is on top, it is on bottom. If you want to make certain changes in terms of color, I can choose the color combinations. So as per your choice, you can choose different colors. Okay. Now, I want to take this particular chart to the output window. Okay. As you can see that insert chart into output viewer. If I click this particular chart one time, it will go to my output window. Look at the bottom of the window, we have output viewer. If I click here, it will go to my output viewer. Okay. Now, come to this particular right side, top of the ribbon bar. Right now, we are seeing the gender frequency, gender chart. We also have one more variable, department. You can see here, we have two variables. At a time, we have prepared the frequency table for the two variables, gender and department. Now, let me go with the department wise. Let me choose some colors. Are you able to see some changes? Okay. Then I want to have title. This is a department title. Right now, it is showing this percentage. If I want to show in decimals, I can show. But I don't want to show any decimals. I want to show in percentage. I can also display labels. This is the label here. Okay, emergency, ICU, output. If I don't want to show the particular labels, I can click on it. Okay. You can also see that frequency plus percentage. This particular asterisk, this particular hash symbol, hashtag. Is it a hashtag? Yeah. Please place the frequency plus percentage. If you don't want it, you can unclick it. And if you want to go for a particular chart, you can able to choose it. Okay. Now I want to see both charts together. I want to display gender chart, department chart in the single view. Okay. So for that, I can click on this two. Now see here, I got both in the same. If you want to take it to my Word document, okay, here I can click on it. I can export it. I can export it. I can also print it. I can also take the printout of it. Okay. There are a couple of options. Next one, I can also copy it, select all, copy, open the Word document, and type it. This is coming in the form of PNG format. It's coming in the form of PNG format. You can see that. Now, let's go to the next part. I just want to make some changes. Like, for example, there are 50-15 population. I'll just make three rows. I'm making it as a male category. One. Randomly, I'm making it male. You can also think of changing it. There are 50-50 population, male and female. Okay. Now, I have done with the three places, in 3 rows. I can say 3 cells. I have changed the gender from female to male category. I have made some difference. Okay. I'm not biased towards any particular gender. Just I want to show some difference. That is the reason. Okay. Now, let's go to the descriptors. This time I want to prepare the descriptive statistics. Like I want to understand mean. Okay. So just go to the descriptive statistics. Now, when it comes to the descriptive statistics, I have stress level is 1. And I have one variable, stress level, quantitative. Burnout, that is quantitative data, we have it. Age, we have quantitative data. When it comes to the conducting mean, we should have some quantitative variables, like age is the quantitative variable. Stress level 1 to 10, we have quantitative variable. Burnout 1 to 10, we have got the quantitative variable. Now I just want to see the mean, standard deviation. I also wanted to see minimum age. I also wanted to see maximum age. Okay. Just click on OK. Now, when we talk about age, we have collected data from 30 respondents. Out of 30 respondents, average age is 35. Average age is 35.60. Means mean age, average out of 30 respondents, average height is 35.6. And lowest age, that is beginning of the age in that particular 30 respondents, 28 minimum age. And out of 30 people, and highest age, that is higher level, maximum age is 50. Okay. Similarly, when it comes to the stress level, 1 to 10, we got 6.77, almost 7. Mean score is 6.7. Stress level is average. 30 people on average, their stress level is 6.7. Burnout, 30 people are on average, if you take the burnout, 6.8 burnout level. So you can see that the stress level is very high. Burnout level is very high among the healthcare workers. Okay. I can also prepare the chart here. When it comes to the chart, for quantitative data, we can prepare the box plot. Right now, what you're seeing, this is called box plot. Like it is presenting data in the form of percentile ranking. I can also present data in the form of histogram. I'm sure those are new to the statistics. I have shared one YouTube link from last 2 days, and today also have shared it to understand the basic concepts of statistics. What is box plot? What is histogram? What is hypothesis? What is null hypothesis? What is alternative hypothesis? What is normality test? So 2-3 days before itself have shared that. Okay, I'm sure some of you might have watched it. If not, please check it out, the link. Now, here I have 3 variables. Right now, I'm seeing the histogram. It is showing the data, how data is distributed with the help of the histogram. I can also see with the help of the box plot. This is called box plot. Okay. This is called histogram. Let me see the age group wise. It shows the people belongs to 28 to 31. There are nearly 8 people. The age group 28 to 31, there are 8 people. 32 to 35, there are 8 people. 36 to 39, around 6 people. So it shows how data is distributed. It is not normally distributed. Let me look at the next one, burnout. So you can see that again, this is called histogram. I can see with the percentages, legends, title, colors I can choose, color combinations. It's not coming color combinations, but unique, same color. I can also put it in my output. Okay. If I have all 3, I want to take all 3 together. In that case, just click on this button. You can see that we have stress level, we have burnout, we have age group. All 3 have taken at a time. So these are the descriptive statistics, and we have done with the frequencies. Now let's go with the cross tabulation. Let's have small theory, a little bit about understanding what is cross tabulation. In this particular slide, you can see I'm talking about cross tabulation and chi-square test. First, let's talk about cross tabulation. When we prepared the first time, single frequency, have taken only one variable, like gender. In our sample data set, not on this particular slide. In this particular slide, is showing 25. But in my sample data set, we got around a total 30 respondents. And 30 people out of 15 people belongs to male category, to 15 people belongs to female category. That was single variable, right? Now, when it comes to the cross tabulation, look at the example here. I just want to compare, for example, as a part of HR. In my department, I want to see how many people belongs to sales. In sales, how many employees we have it. In marketing division, how many employees we have it. In engineering division, how many employees we have it. Okay. In total, I have 55 people. Total, let's take an example. Total here 50, 25, 15, 60. Total 25 plus 30. We got, how much we got it? 55. Total 55 employees we have. Out of 55 employees, how many people belongs to male category? How many people belongs to female category? Within that, how many people belongs to sales? How many people belongs to marketing? How many people belongs to engineering? If you want to get more insights, if you want to bifurcate the data, I don't want to simply talk about for every variable one table. I just want to see 2 variables together so I can get able to better insights. For example, if I have 2 variables, one is gender, second one is academic level of the faculty members, like assistant professor, senior professor. Now, if I have single variable, it won't make any sense for me. But if I can able to see gender and academic levels, so I can talk about whether the people belongs to assistant professor, are they performing more? Who are the people are belongs to higher positions? Let's take for example here. Here I'm preparing the gender. Here I'm preparing the academic level. Now, if you're going to start preparing number of individual single frequency tables, don't give me any scope for me to come up with any insights. But if you can able to prepare some cross tabulation, like taking two variables together, one is gender, second one is academic performance or academic level of employees. So I can able to get best insights from my data. So in that case, I can able to come up with best insights from my data as a part of it. So cross tabulation that way is going to help us. Let's come with the cross tabulation. Please go to your data set. Please open your data set. There is an option called compare groups. There is an option called compare groups. Come to the cross tabs. Now I opened the cross tab window. I need two categorical data. For preparing the cross tabs, I need two variables. I'm choosing gender, row wise, department, column wise. You can choose randomly also. For preparing the cross tabulation, I need two variables. Okay. Gender, I have selected. Department, I have selected. Just click on OK. Now look at here. There are total 30 respondents in the data set that I have given. In this particular data set that I have given to you, 12 people belongs to female category. Earlier we got 15, now it is 12. Why? Because we have manipulated. We have changed the certain rows. I hope you are able to see the difference. Female, we have 12 respondents, and males, we have 18 respondents. Now, within female respondents, how many people are working in emergency department? How many people are working in IC department? How many people are working in outpatient department? Okay. Similarly, I can also get the insights. I can also able to understand with reference to male category, how many people are working in different sectors. Okay. So instead of talking, there are 12 female employees, 18 male employees. Instead of talking, 10 people are working in emergency, 14 people are working in ICU. I can able to get the clear picture, not only gender-wise. Along with the gender, I can also get in which department they belongs to. Right? So I can also prepare the chart. Look at it here. On the top of the ribbon, we have chart option. You can go with the vertical chart, or in case we are interested in a horizontal. On the top right side, bar chart is there, horizontal. So you can choose which one you want to design, which one you want to prepare it. Now, right now it is presenting the percentages along the decimals. I want to go with only percentage. You can choose. You want legend, grid lines. If you don't want grid lines, you can choose for it. Title, if you want to title, gender and department. Okay. Color combinations. You can choose the color combinations. Okay. And come to the table again. We got the table. Now, I just want to go one level higher. Instead of talking about cross tabulation, I just want to go with one level higher. That is, I want to conduct the chi-square test. The difference that I'm seeing right now, whether it is having any statistically significant difference, like the people belongs to male, gender, and working in a particular department, is it having any association? I want to see that. Okay. So if you want to conduct the chi-square test, I just want to see whether is there any association between gender and particular department. Like here, we have two categorical data. One is gender, second one is department, right? So here, variable 1 is the one categorical data, gender. Variable 2 is a categorical data. That is also department. We have 3 categories. My null hypothesis to conduct the chi-square test, there is no significant association between healthcare workers, gender, and their perceived level of management support. Now here I can choose different variables. Either I can go with gender and perceived level of management support. There is another variable. Okay. Or I can choose gender and department level, like as per the current table that we have gone. Gender and department, we have already done with it. So if you want to go with the next level, there is an option called chi-square test. If you look at my screen, there is an option called association measures. Whenever you have two categorical data, like gender, we have nominal data. Department is a nominal data. They belongs to categorical data. So in that case, I can go for conducting chi-square test. So if you want to conduct the chi-square test, you can see there is option here, association measures. The moment I select the association measures, chi-square test results, I got it. Now, how to understand this particular table? I'm sure all of you knows, some of you are new to the statistics. So let me talk about what is p-value here. Whenever you conduct a statistical test, we always look for our p-value should be less than 0.05. Let me show you the data. Whenever we conduct statistical test or whenever we're conducting hypothesis testing, we always look for our p-value should be less than 0.05. Means we are going to reject the null hypothesis. Generally, what do you do in a null hypothesis? There is no difference between, or there is no association between gender and department levels associated with the departments. Now, if p-value is going to be less than 0.05, it means there is a significant difference. There is a significant association between gender and department. Now, in case if a p-value is going to be greater than 0.05, if it is p-value is going to be greater than 0.05, we fail to reject the null hypothesis. Means there is no difference between gender and department. There is no okay. As for our hypothesis, when it comes to the chi-square test, what is our hypothesis? There is no significant association, our null hypothesis. If your p-value is less than 0.05, if a p-value is less than 0.05, we are going to reject it. Null hypothesis. It means there is a significant association between healthcare workers' gender and their department. But in case if our p-value is greater than 0.05, it means we fail to reject the null hypothesis. Instead of saying we are accepting the null hypothesis, we are going to report in our report saying that we fail to reject the null hypothesis. Means there is no significant association between gender and department. Let me go ahead to this slide once again. If our p-value is less than 0.05, means there is a statistically significant difference or association between the two variables that are selected. But in case if your p-value is greater than 0.05, it means there is no statistically significant association between the variables that are selected. It means fail to reject the null hypothesis. Now look at our test result. Our p-value is 0.17. It means it is greater than 0.05. It means we fail to reject the null hypothesis. The conclusion is that there is no significant association between gender and department. There is no significant association between, means there is these particular variables are not associated. Okay. Now here, when it comes to the table, you can see the percentage wise also can present it. Column percentage, row percentage also you can able to take it. If you want to see only frequencies, that also can be presented. This is called cross tabulation as well as chi-square test. Okay. Now we are going to conduct the independent sample t-test. What is independent sample t-test? Comparing independent groups. If you want to compare based on certain categories, in that case, one can go with comparison-based tests like t-test. Within t-test, we have three types of statistical tests like one sample t-test, independent sample test, paid sample test. Now the question is, when it comes to the MAXQDA, we have only two. When it comes to paid parametric statistical test, we have only independent sample test. Non-parametric statistical test, we have Mann-Whitney test. Now, when I talk about the independent sample test, if I want to measure, is there any difference? We see real or is it just luck? Every research analysis starts with the question, what are the seeing the difference? Is it real? Is it statistically significant? Or it's happened by chance, by luck? Okay. Let's take for example, whenever I want to conduct comparison-based test, how to choose? As a researcher, I'm getting confused. What kind of statistical test I have to choose for the variables that have it? Like for example, compare two groups. I'm comparing like gender and male and female. I have two groups. Please listen to me. If I'm comparing two groups with metric data, if I'm comparing that slide. For conducting independent sample tests, we required one dependent variable that must be quantitative data. It can be either interval or it can be ratio. Interval data must be interval. It can be interval or it can be ratio. That must be dependent variable. Second one, I should have independent variable that must be categorical data. So dependent variable must be quantitative. Independent variable must be qualitative. Let's take an example here. In my example, there is no significant difference in the mean stress level between male and female healthcare workers. Now, what are the variables I can see? There are two variables. One is gender. I have two groups, male and female. That is independent variable. Second variable is stress. Now, whenever I have two groups, male, female, that is categorical data. Stress is dependent variable. That is quantitative data. Now, whenever I have two groups, I'll go for independent sample test. Imagine that I have assistant professor, associate professor, professor. It means more than two groups I have. In that case, I'll go for ANOVA test. If I have only one and two, like male, female, I'll go with independent sample t-test. But if I have third category, I'll go for ANOVA statistical test. So in this particular current example, I'm just trying to understand stress among the healthcare workers, that is males and female healthcare workers. Okay. I want to test it. My null hypothesis is that there is no significant difference in means average stress level between male and female healthcare workers. Whereas when it comes to my alternative hypothesis, there is a statistically significant difference in the mean stress level between male and female healthcare workers. So I'm going to conduct this particular statistical test with the help of the MAXQDA. Now, before conducting the statistical test, at the beginning of the session, I have mentioned that within an inferential statistical test, we have two types of statistical tests, parametric, non-parametric. As for the statistical test, parametric statistics considered more rigorous, more reliable as compared with the non-parametric statistical test. But how to differentiate or how to decide when to go for parametric, when to go for non-parametric? Every statistical test has certain assumptions. There are common assumptions. Apart from the common assumptions, there are specific. Like for example, if you are going for assistant professor, you have specific eligibility criteria. Basic criteria is we have, and required eligibility criteria we have it, right? So every statistical test have certain specific requirements. Like normality test is common for any type of statistical test. Now, some of you can ask me, what is normality test? I'm not sure how many of you watched the video that I have shared with you all. Imagine that I collected data from around 100 participants. Okay. I collected data from 100 participants. Now, when I prepare the histogram, it is going to show me that how my data is distributed. How my data is distributed. Let me put it another example. I'm talking about my Gujarat National University GNLU placement record. Okay, we proudly say that we got good placement compared to last year. Our ranking is improving. Maybe in terms of placements, we are able to perform very well thanks to the placement department. Now, as a faculty of the GNLU, if somebody asks, Dr. Kalpesh is asking, sir, what is your annual package of your student? Let's take, for example, if I'm taking the example from 5 students ranking. I'm collecting data from 5 students. First student got 20 lakhs. Second student, 22 lakhs. Third student, 15 lakhs. And fourth student, we got around 20 lakhs. Fifth student got around 2 crores. 1 to 4 in terms of lakhs. The last one is in terms of crores. Now, if Kalpesh Gupta, Dr. Kalpesh is asking me, what is the annual package? Forget about GNLU. Just generally, whenever you're calculating average, mean score, how will you get it? Total number, this total divided by number of students. So 20 plus 22, 42. 42 plus 15. I need to use the calculator. Very poor in statistics. 42 plus 15 plus 22. Got it 77. 2.2 crores 77 lakhs is the score. Now, if I divide it, 2.77, 2 crores 77 lakhs divided by 5, how much I'm going to get it? Average. Anyone? Any respondents? Any volunteers? 2.2 crores 77 lakhs divided by 5 people. How much I will get average? Imagine that I'm getting around 55 lakhs. Annual package, I'm going to, based on this particular score, I'm going to say that my students are getting annual package 55 lakhs. But is it correct? If you look at the first four, 20 lakhs, 25, 22 lakhs, 15 lakhs, 20 lakhs. Just because there is one number which is deviant, which is very far away from the rest of the 4 members, it is affecting the conclusion of my results, or the conclusion that I'm going to give you here. 55 is not actual reality. 20, where is 20? Where is 55? If I do it 20 minus 55, I'll get around difference 35. 22 minus 55. So you can see the lot of difference. Now here, the mean that 55 I'm saying here, that is the mean here. This is the mean. Mean is equal to, median is equal to mode, average. Now the problem is that just because there are outlier, this is outlier, means it is very far away from the rest of the mean values. Just because of this outlier, it is affecting my entire data. So what I have to do is, either I have to delete this particular outlier. If my sample is good enough, like around 380, 400, I can simply delete the particular respondent entire response. But otherwise, if you don't want to delete the particular respondents, and what you have to do is you have to increase your sample size. So you can see whether, depends on your situation, whether you can able to delete this particular entire respondents, or you can able to collect the further data. So if my data distributed normally, there is one assumption I can go for normality. I can show that I am able to distribute normality. Where it is, yeah. So we are going to conduct a normality test. For conducting normality test, we have a lot of statistical tests like Sperry-Wilkie test, histogram, box plot, skewness, kurtosis, stream leaf. There are so many statistical tests that are available, but you can take one of them. Like if you want to take in terms of statistics, you can go with the Sperry-Wilkie test as a part of the choice for you. Now, if you want to use Sperry-Wilkie test, again, I have to have my hypothesis. My hypothesis is that, look at here, my null hypothesis, sample is normal. My null hypothesis says that sample is not normal. After conducting the normality test with the help of the Sperry-Wilkie test, if my p-value is greater than 0.05, if my p-value is greater than 0.05, I fail to reject the null hypothesis. What is my null hypothesis? Sample is normal. But in case, if my p-value is less than 0.05, I'm going to reject it, my null hypothesis. What is null hypothesis? Sample is normal, means I'm going to reject, means my sample is not normally distributed. I hope I'm able to make it clear. As a part of normality test, we have so many tools are available, like histogram, box plot, normal QQ plot, skewness and kurtosis, but you can use one of them. The best one is you can think of using Sperry-Wilkie test to understand whether your data are distributed normally. Second assumption, for conducting independent sample test, another important assumption is that I'm showing that I'm able to fulfill, I have two groups, male group and female group, and there is an equal variance. I'm assuming that these groups, they're not different. In terms of data, we assume that the spread, we got the male score, we got the female score, right? But I'm assuming that both the groups, there is no variance in terms of their performance, in terms of the stress level. I mean, assuming that they are having equal. Okay. Now I'm going to conduct Levion test, that is homogeneity of the variance test, as a part of independent sample test. And it is also common for ANOVA test as well. Now, if my p-value is greater than 0.05, equal variance assumed. If my p-value is less than 0.05, equal variance is not assumed. Look at here. If my equal variance assumed, it means my p-value should be greater than 0.05. So that I can say that there is an equal variance among the both male and female employees. But in case my p-value goes less than 0.05, it means there is no equal variance among the groups. So that is another my assumption for conducting independent sample t-test. So let's go with the how to conduct it. Go with the data. Please open your data set. There is option called compare groups. There is option called compare groups. Just click on t-test for independence. T-test for independent samples. Now, for conducting independent sample t-test, we require two variables. One is a dependent variable that must be continuous data. I'm selecting stress level, like we have 1 to 10. I require second variable that is categorical data, like I have gender. I'm selecting under groups, like female, male, we have got it. Click on OK. Now look at the results. We got the homogeneity of the variance test. Our p-value is 0.23. It means it is greater than 0.05. Look at here. Our p-value should be greater than 0.05, means equal variance assumed. So look at our output here. It is 0.23. It means it is greater than 0.05. There is equal variance among the males and female respondents. Now, look at the descriptive statistics. There are total 30 respondents, and we have 12 female and 18 male categories. And I want to see the stress level. Who is having high stress level? Whether males are having, male employees, male healthcare workers have more stress level or female. If you look at the mean score, as compared with the female employees, males have higher level of stress. I can see there is a difference between male and female around 0.30, somewhere close to 0.30 difference I can see. Very nominal, very less. I can say the very negligible stress. Okay. But I want to see the kind of difference. Is it happened by chance or is having any statistically significant difference? For that, we conducted independent sample t-test. Our p-value is greater than 0.05. It means there is no statistically significant difference between male and female with reference to their stress level. Our p-value is greater than 0.05. It means there is no significant differences in the mean stress level between male and female healthcare workers. I'm sure there might be some early research scholars. If you want to type it, how to interpret your findings, how to report in your report. T-test was conducted to compare the mean stress level between male and female healthcare workers. The results indicated that no significant differences in stress level between two groups. The p-value for both homogeneity and heterogeneity of the variance test exceeded the 0.05, indicate that no significant differences. This suggests that gender does not significantly influence stress level in this sample. With reference to this particular sample, with reference to this particular data that we collected, gender does not statistically significantly influence the stress level. There is one more important point. Imagine that we got the significant results, but I'm conveying to layman. I'm telling to my findings with some layman. I'm just presenting my findings. The layman cannot understand what is, if I say that there is a significant difference. But I want to convey them. I want to reach everyone what it means, my findings. For example, I got the result. Let's take, for example, in this particular case, effect size. For Hindi effect size, right now we got it minus 0.1. 0.1 we got it. Okay. Just imagine that whenever you got the significant results, like 0.2, 0.4, 0.5, 0.8. Now, if I want to convert into percentages, if it 0.2 means 58%, instead of simply saying that there is a significant difference between significant difference between males and females with reference to a stress level, 58% there is a difference between males and females. Or 69% there is a difference between males and females. How much effect we have it? How much effect stress level we have it when you compare between males and females? So effect size is very helpful to convey your conclusions, your findings from the layman point of view. Okay. Come to the one-way ANOVA. One-way ANOVA, basically we use it when it comes to comparing more than two groups. Look at the test results here. We'll use t-test when we have two groups, like urban area or rural area, central university, state university, right? Whenever we have two groups, we'll go with the independent sample test. But in our study, I'm looking at the stress level among the people those are working in ICU, the people belongs to emergency department, the people belongs to outpatients department. So here I have more than two groups, like 1, 2, 3. So in that case, I can go for one-way ANOVA test. Okay. My purpose is stress significantly different between the people those are working in ICU, those are working in emergency, those are working in outpatient department. So when it comes to the conducting ANOVA test, my hypothesis says that all population means are equal. If I convert into my case study device, the mean stress level are equal across the ICU, emergency, and outpatient. I collected data from the people. Those are in 3 departments. I'm saying that irrespective of the department they're working on it, their mean stress levels are equal. There are no differences. That is my null hypothesis. When it comes to alternative hypothesis, at least one department has significantly different mean stress level as compared with the other departments. The alternate department hypothesis does not tell us which department is, but test results help us to understand whether ICU have high level as compared with the emergency. So I can able to differentiate ICU with emergency, ICU with outpatient, ICU. So I can able to see with one department with the rest of the two departments. I can able to compare it. My goal, just like independent sample test, we are going to conduct homogeneous variance test, or PLU should be greater than 0.05. I'm not going to repeat it because we have already conducted while conducting the independent sample test. I don't need to discuss much again. We are assuming that the employees belongs to ICU, employees belongs to outpatient, employees belongs to homogeneity. We have equal variance among the groups. Okay. So here, the ANOVA test help us to understand between the groups, within the groups. So with the help of the F value, we are going to interpret the results. Like for example, if F is close to 1, groups are similar and there is no significant difference. If F is large, between the group variation, a statistically significant difference exists. Between the groups, within the groups, with the help of the test, we are going to conduct how it is. Let's come to the results. Please go to the compare groups. There is option called analysis of variance. Now, what are the data requirements here? I need a categorical data that must have 3 groups. Like we have department, which is having 3 groups. It comes under factor. I need one dependent variable that must be quantitative data. Here I have stress level. Okay. Just click on OK. Now look at the homogeneous variance test result. It is greater than 0.05. It means equal variance is assumed. Now coming to the p-value. P-value is greater than 0.05. It means there is no significant difference between department and stress level. Means all the people who are working in different departments, there is no difference. Irrespective of the department they are working, they have equal level of stress. Equal level of stress they have it. Okay. Now, just come to the next part. Last test we have correlation test. I have already shown you what is effect size here, how to differentiate it, how to interpret it. With the help of this figure, it is 58%, it is 69%, it is high, large percentage effect size. Okay. Now, within the ANOVA test, we have big family. Maybe the scholars, those who are working in statistics, you know that right now we have done one-way ANOVA. For conducting one-way ANOVA, we have one nominal data, one nominal variable like ICU, emergency. There are 3 one nominal data, one scale data we have it. In that case, we'll go with one-way ANOVA test. Okay. In case one nominal, 2 scale data we have, we'll go for one-way MANOVA. If you have 2 nominal variables like effect of education and experience on income, and we have 1 scale data, in that case, we'll go for 2-way ANOVA. 1 nominal plus 1 scale plus 1 nominal scale, we'll go for ANCOVA. There are different statistical tests. I don't want to confuse right now. Last one, correlation test. The main objective of correlation test is to help us to understand strength and direction of relationship between 2 quantitative variables. For example, I'm thinking somebody's annual income is increasing, whether annual expenses increasing or decreasing. If annual income increase, annual expenses also increase. It's called positive correlation. But annual income increase, annual expenses decrease. It is called negative correlation. If you want to conduct correlation test, there should be linear relationship. Means either you should have a positive relationship or negative relationship. Okay. In order to conduct the linear relationship correlation test, we need to fulfill 4 assumptions. Like there should be linear relationship. It can be positive or it can be negative relationship. Second one, we must have variables, 2 quantitative variables, like annual income, annual expenses, 2 quantitative variables, we should have it. Independence of observation. Every variable has its own data and we should conduct normality test. So these are the 4 important assumptions one has to fulfill for conducting correlation test. Positive correlation. If one variable increase, other variable is decreasing. This is called positive correlation. One variable increasing, other variable decrease. It is called negative correlation. And there is no increase or decrease. It's called no relationship. Whenever you get this kind of result, you can't conduct correlation test. If you get either positive correlation or negative correlation, you can go for conducting correlation test. But if you get this kind of result, you can't go for conducting correlation test. You're not eligible to conduct the correlation test. Okay. So I'll talk about interpretation part in coming slides. Now, what is the example that we have? As a part of the data that I have given, we are investigating if a support to management team correlates with happier employees. I'm saying that there is no significant relationship between management support and job satisfaction. As a part of our data, we have 2 quantitative variables. One is management support, secondly, job satisfaction. I want to see if those are having higher management support, are they having good satisfaction, high satisfaction or low satisfaction. I'm just going to conduct this particular test. Please come to the correlation. There is an option called PSN correlation test. There are 2 types of correlation, PSN correlation, Spearman correlation. If you are able to fulfill the assumptions of PSN correlation, like having 2 quantitative variables, having linear relationship, having normality distribution of the data, you can go for PSN correlation. If you are not able to fulfill the assumption of parametric statistical test, in that case, you can go for Spearman correlation. You can also go for Spearman correlation whenever we have ordinal data. Okay. Let's take, for example, I'm choosing job satisfaction. Like I can choose management support also, I can choose what stress level also I have to choose. Let's take this one. Okay. Look at here. Our p-value is less than 0.05. It means there is a significant relationship between job satisfaction and management support. If one variable increasing, if there is a good support, obviously there is going to be good satisfaction among the employees. Means there is a high positive correlation between the employees. P-value is less than 0.05. It means there is a statistically significant difference between management and job satisfaction. If management is increasing, job satisfaction also increasing. But correlation test not only helping us to understand whether there is a statistically significant difference, it's also telling us strength of the relationship. Now, how to understand the strength of the relationship? Come to this particular value. If my value correlation R value is close to 1, like in between 0.9 to 0.1, it means very high positive correlation. But if I'm getting result in terms of minus, like minus, then very high negative correlation. Depends on the minus and plus, you can see whether it is going to be positive or negative. Now looking at our test result, 0.967, it coming under 0.967, very high positive correlation between management support and satisfaction of the employees. Okay. Now, when it comes to the linear relationship, if you go to rest of the tools like what to say, SPSS, Jamovi, or any other statistical test, if you go, we have scatter plot. Scatter plot help us to understand whether there is a positive relationship or negative relationship. Like for example, if one variable increasing, other variable is increasing or decreasing. Like x-axis management support, y-axis you have job satisfaction. Now job satisfaction is 1 to 10. Management support 1 to 5 we have it. Means if somebody is saying that management supporting up to 5, whether what about the job satisfaction level, right? So if one variable increases, other variable increasing or decreasing. The scatter plot gives us general idea of the relationship. So we can see that how one variable increases, other variable also decreasing on. That's why it is going to help us. Before going to other statistical tests, let me briefly summarize what we discussed. If you want to conduct independent sample test, you require 2 variables. Like it can be private university, public university, gender, female, male, female, right? You're trying to understand relationship between 2 categories. We required 1 dependent variable, that is quantitative data. Second variable must be categorical data. Okay. So if you have 2 variables, t-test. If you have 3 variables, ANOVA test. When it comes to ANOVA, we have 3 categories like group A, group B, group C. Like how we have emergency, ICU, outpatient, we have 3 categories we have it. Okay. And you can able to see that we are able to see between the groups, within the groups, we are able to compare. Okay. And correlation test, whenever there is a linear relationship, it can be positive, it can be negative. You can go for conducting correlation test. We require 2 quantitative variables. It can be either ratio data or interval data. In that case, you can go for Pearson correlation test. And in case we are not able to fulfill the assumption of Pearson correlation, you can go for Spearman correlation test. Okay. So this is all about it from my side. Let me see if there are any questions. Session is open for question and answers. Let me see your chart. Dr. Sangeeta, sir, can you show an example where data is not according to, and what is NPC, madam? What will be the next step? NPC. Next one, Dr. Sangeeta, in the meanwhile, can you type what is NPC? Professor Mahesh, thank you, sir. Thank you so much. R. Kannan, how to prepare document and code variables? D. Nova. For example, we have documents and we have prepared the codes. We don't have external Excel file defining the variable, which we can conveniently import. In fact, we have to create variables, how to do it. I'll show you this. After taking question and answers, I'll show you how to create the variables. Total should be 70. Yeah, there was some mistake, madam. Professor Dr. Sahu, thank you. I'm talking about 55 with 1 column. Okay. Total 55 of the total, 1 particular column. At this stage, is it required to change the measure from nominal to interval? I think we have answered at that time. Excel sheet are not visible, not available. I think earlier questions. How to make histogram in MAXQDA? Dr. Varsha, I think you have missed the session. While showing the descriptive statistics box plot, I'll show you once again right now. Don't worry. Normality, probability curve, same histogram. We got the data here, but what if we have to enter the data by ourselves? Yes. So same question. Let me show you right now. I'm sharing my screen with you all. I'm just going to the data editor. I'm going to the data editor. If you look at the variable list, variable window, here, I'm going to type here. Like, for example, I want to type one more variable. I want to enter the data manually. Right now, we have imported the data that I given to you. We have imported maybe Google form or the Excel data that we have. But if I want to type manually, how I can type it? So here I want to type it the like annual income. Annual income is the one variable. Annual income is one variable. I have typed it. And it is integer. Yes, annual income, if I'm going to put in terms of numbers, it is going to be integer. But if I'm going to give particular text like less than 5,000 or particular categories, I'm going to put it in the form of text. Now, as it's going to be integer, it's clear. That is one thing. Now, I just want to type one more variable. So I can go to file. I can go to the variables. Here I'm going to type one more label, like I just want to understand APA score, academic performance index. See that I got the academic performance index. I'm able to type it. Academic performance index for assistant professors. Next one, associate professor. So whether it is manually or whether you want to import it, you can see this, how you can able to type it. Now I have one more category, professor. There is option that, for example, some of the scholars says that my guide suggested me to, while collecting data, I asked, what is your age? Like 28, 28, 29, 29, I got it. But my supervisor suggested that I need to convert this particular data into certain class intervals. So I have certain data transformation technique. Like I just want to reorganize this data without disturbing this particular column. I want to have one more column with the age, but it should be in the form of class interval. So I can see that minimum age is 28, maximum age is 50. We have done earlier, right? Now let's go to transform. There is an option called recode into new variables. Recode into new variables. Now I'm selecting age, old variable. I'm going to come up with a new variable, means I am not going to disturb the existing column. New variable title is age 2. Okay. Now, what no values I'm going to have? I want to create class interval like less than or equal to 35 should be considered as 1. Okay. Or young age. I can type it like young or 1 value. Less than, greater than or equal to 35 means those are less than 35 or less than 35. We are going to consider as a 1 category. Those are above 35. We're going to consider them as a 2. Okay. Look at here. I got the age 2, 2, 2, 2, 2, 2, 1, 1, 1. Now come to the variable list. Here I'm going to give the label. One for young people. Or I can also say that less than 35, something like that. Young people. 2 for elderly people. Just depends on the context of the study. You can able to define how you want to define them. Now come to the data view. See here, elderly people, young people. See. So you can able to convert by using certain data transformation technique. That also possible. I think last one you're also asking about how to prepare the histogram. In order to prepare the histogram, go to descriptors. We are going to prepare the histogram for quantitative data. Like here I can see that I have 3 quantitative variables, like age is a quantitative variable, Burnout is a quantitative variable. Stress level is a quantitative variables. Okay. But these three variables, I want to have mean as well as histogram. I want to prepare it. I have prepared it earlier. I have already shown earlier. Some of you missed it, so I'm showing again. So I can able to see that normality curve, histogram. This is for the stress level. In case we have missed, please watch it again, recording session sometime. Okay. I already covered this particular part. Age again here. See that the histogram, box plot can be done. Okay. This is okay, one documents, but what about several different types of documents? How to create variables for them? If you have several different type of documents, each document you have to import separately. Okay, because you can't club two respondents together. I mean, two different stakeholders together. You can integrate the findings of one study with another study. Let's take, for example, I'm collecting data from the teachers as well as students. I have students have different purpose and teachers have different purpose. But I want to combine their findings together. That's what we are going to do tomorrow. Okay, you can join for the tomorrow session, where I'm going to talk about combining quantitative with the qualitative, or combining two different data collection methods together. Okay. You're asking about deductive inductive. Please watch yesterday's session. It was uploaded in the Google Drive link. Bike, sir, my MAXQDA keeps crashing and is hampering my hands-on learning. I reinstalled. It is the latest version 2, but problems still persist. Look at your Java. Look at your space, the amount of space that you have with reference to the RAM. Okay, that might be the compatibility is the most important aspect. If required, maybe you can copy some files. Ensure that you have sufficient space while working on it. Can you please suggest any book? Dr. Sangeeta, yes, I'll be uploading some good books, step-by-step quantitative data analysis steps in the Google Drive link. By tomorrow, we are going to see that, definitely. Simon, is the exporting of the results of Statistical going to be like the same you showed? Yes, you can export as the same. How to make histogram? I think this question was answered. Dr. Seema, thank you so much. Thanks a lot. If those who are new to the statistics, I request you all, please, you can have some reading materials, which I'll be sharing tomorrow, Google Drive link. Okay. And I don't want to say myself, but I tried my best to explain in terms of how to test the hypothesis, how to frame the hypothesis. So you can look at my YouTube channel. You can, here I'll show you once again that you can scan this. You'll find about SPSS, you'll find about Jamovi, you'll find good number of videos with reference to basic statistics to advanced level statistics. You'll find it here. Those are interested, please subscribe to this YouTube channel. You may get maybe helpful information. Okay. So tomorrow we have last session that is going to be mixed method data analysis. At 6:55, you can see sample data sets. Maybe I'm going to come out some sample project. You can find some sample projects before coming to session. Around 6:30 to 6:55, you can check your Google Drive link. I'll update in the Google Drive link. Okay. So this is all for today. Any questions before ending the session? Professor Deeparan, thank you so much. Thank you. Thank you all. Munjan sir, thank you. Thank you all. Thank you everyone. Thank you. Dr. Kalpesh, I think we can end the session. Yes.